Okay. Uh, so yeah. Hello friends. Good morning, good afternoon, and good evening to all of you, based on where you are located. I hope all of you are doing good and staying safe during the challenging times. My name is Mayur, and I welcome all of you to this first session where we will discuss about software engineering in first part, and then we will do tutorial. And after that, we will discuss some course logistics. Okay, how exactly you can access data which is stored on OneDrive folder, how exactly you're supposed to submit your assignment and other part. So that's something we will talk about today. But yeah, so for now, just try to focus on first part, that's like software engineering. Okay, and then we'll go for tutorial, but just for now, try to focus on this theory part. So software engineering is really important thing when it comes to our coursework. This session was not included in like earlier hands-on control programs, but when I was talking to those student or participant, I realized like students are really in need to have some session on Python and as well as on data structures or algorithms. But they were having some issues understanding data types. Sometimes they were really not able to understand few commands that means we were using later on, means for like later tutorials. Okay, so that's the reason I have decided to include this session in the beginning. And for this session we will discuss two things. First of all, we will discuss programming in general, what are the principles which are there, and then we will do some practice using Python programming language. So as I mentioned, like it was need which I realized when I was discussing with participants, that like software engineering or knowledge regarding programming is essential. But apart from that, there are like a lot of things that we need to consider uh, because the software engineering field itself is involved a lot in design of very means many modern complex system. Okay, so if you are like good at software engineering, then eventually we will be able to design more and more complex and um, more evolved systems. So that's the reason behind I have included this session in the beginning. But when it comes to software engineering, there is one more thing, uh, programming. Okay, so programming is just not the way, or it's just not the means it just not like some sort of part of our coursework or curriculum. Rather, is the way in which we can think about particular problem. Okay, so it provides us with convenience to explore and express our ideas more effectively. So that's the reason it's really necessary for us to learn programming so that we would be able to express ourselves more effectively and robustly and deliver what exactly is asked from us. So that's the reason for us to like study programming. For this coursework or for this session, there is one theme that I want to maintain, and that theme is about abstraction and modularity. Let it be any system, or let it be program, or let it be anything. When you want to scale that thing up, the only thing that we should consider in the beginning is that the thing that we are starting from should be modular. Okay, so what we will do today, so we will start from like microscopic scale. We will try to understand what exactly programming means at the level of line, and then we will try to scale it up further for more complex problems. Okay, so that's about modularity, and then about abstraction as well. We should be able to use those concepts in more efficient ways to build bigger and bigger system. So that's something abstraction means over here. Okay, so these are the two properties that I want to maintain throughout this session, and using that those properties only, I want to explain this entire programming framework to you. Okay, objective, as I mentioned in the beginning as well, my objective for you to include this session over here is to ramp everyone up to the level where you could handle basic programming, and you should be able to work on tutorials that we will do this month or next month. Okay, so that's the objective. And means we will do this session, we will do tutorial as well, okay, using Python programming language. But apart from that, I also want you guys to commit to some routine where you will go to HackerRank platform or LeetCode platform, and for every day you will try to solve one question from Python segment and one question from data structures and algorithm segment. So that commitment is something I need from your end. Okay, So if you do that thing, then you would be able to give your best somewhere down the line, maybe 3 months or 4 months. You would be like really great at programming, and you would be able to solve a lot of problems. So that's something like a hefty goal that I have in mind to include this session over here. Okay. So this is our agenda for this session. In the beginning, we will discuss about basics of computation. Uh, I'll try to include how exactly computer thinks. Then I'll try to include some hardware part, and then we will discuss about software. And then eventually we will discuss how exactly this hardware plus software combination can be used to build basic architecture, which we can use later on to solve or like solve some simple problem. Okay, so that's something we will see in the beginning. Then I'll talk about programming languages. The way we have like for humans, we have our own language, right? We use words, we use phrases, we use sentences to like talk to each other, express our ideas. In the similar way, computer also have their own language, but there is like abstraction over there. Okay, some languages directly interact with hardware. Some languages need like some sort of conversion or interpretation to be done in order to computer to understand that thing. So there are various levels, so we will talk about that as well. So basically there are three languages. They can be put into three categories. First is a high level language, then there is a assembly level language, and then there is a machine level language. Okay, basically computer understand machine level language only, but we will also talk about all those levels since we're gonna discuss about this programming framework. Okay, so you would understand where exactly we are, and in order to computer to understand what we are writing, what all step it need to go through. Okay, so we will discuss that part as well. Then I'll talk about Python interpreter. So as I mentioned, to move from like that high level language to machine level language, what are all steps that computer performs? So that's something we'll discuss. Then, so here I have mentioned objective for this session to learn the PCAP principle. Okay, so PCAP principle is basically primitives, to study about primitives. Whenever there is any programming language, that programming language always follow this principle, PCAP principle. So it's like abbreviation. So P means primitives. Okay, so whenever you have to build anything big, you should start with primitives. Then you should compose, you should do composition of those primitives to get something bigger. So that's the second thing. That's the combinations. You do combination of those primitives, and you end up getting data structures and some control flows or like sequence of operations. So that's the combinations. Then there is abstraction. We really don't just want to have like data structures with us, or just these complex sequences with us. Rather, what we want to have, we want to use that thing repeatedly again and again and again. Okay, and in order to use that thing, we should be able to write that thing in a very simple way whenever we want to call that thing or whenever we want to use that thing. Okay, so to have that thing over there, what we need, what our programming language should have, it should have a property of abstraction. Okay, so that's something we will discuss, and then we will go for patterns, because whenever you are having these compositional properties and then properties of abstraction with you, it will be easier for any programming language to scale up, to build complex system out of it. Okay, so we will talk about that patterns as well, and then we will conclude this session after talking about binding environment. Okay, so this is our agenda for this session. Yeah, so let's get started with our first part. So basically, guys, what happened? Whenever we look at any computer, that computer basically perform two things, two tasks. So first thing it does, it stores whatever information or whatever data provided to that computer, and second operation it performs is calculations or like operating on that data which is being provided to that computer. So these are the two tasks that any that computer performs. But in order to perform those tasks, computer need to have some sort of arrangement over there, right? So that arrangement is something provided or like is available over there in the form of hardware. Okay, so let's discuss that part as well. Okay, because here we have two tasks. First is we want to store that information, and second task is like we want to operate on that data. So when we have to do these two tasks at the level of hardware, so we again will start from basic level, microscopic level, and we will understand what is that basic element which is letting us do that stuff. Means task of storing and task of performing some operation on that data. So basically what happens whenever you look at any electronic circuitry, the you might have like heard about logic gates during your bachelor or master studies. So basically there are like AND gate, OR gate, NOT gate, then there is NAND gate or NOR gate. So basically these are logic gates, and those gates allow us to take input in some form, and they operate over that, and they give us output in some form. So basically those are gates which are which are just trying to alter the level of that signal uh, when it moves through that particular block. But that's the simple block which is available in electronic circuitry, and that's something we cannot use directly to store particular information or like do some complex operation on that data. So in that situation, what we do, so as I mentioned, like we have NAND gate. So basically it's like inverted AND gate. So we use 4 NAND gate in a such a way that we would be able to get 2 outputs, and we would have like 2 inputs. Okay. So when we take 4 NAND gates and when we place in some fashion, we will have like 2 inputs. Basically those 2 inputs are like set pin and reset pin, and it will have 2 outputs. Okay. These 2 outputs is something allow us to store information in some format, and whether it will store same information or it will store different information, it totally depends on like clock input that will be provided to this uh, a circuitry. Okay, and that circuitry is something we call as a flip-flop. Okay, so we start with logic gates. We consider like bunch of logic gates, like 4 NAND gates. We combine, we put them in some order, and then it becomes flip-flop, and that flip-flop is something allows to store 1 bit of information. Okay, and so this is something allowing us to store 1 bit of information. When we put like a lot of flip-flops together, it becomes a register. It could be like shift register or storage register, and it allows us to like store like much means large set of data. Okay, and when we use them in like some this when we use this basic circuitry in some proper order, we would be able to get like certain tasks done as well. Okay, so we can also use this thing to build counters, timers, and other things. Okay, so we would be able to get basic operation done on that data, and we would be able to store that information as well. Okay, but thing over here is that we have hardware with us which we can like scale up, and we can like build really complex system with us. But so as I mentioned, we will need clock pulse which will tell us, or which will tell that hardware what should that hardware do. Should it maintain same state or should it change its state? Okay, and when exactly that clock pulse should be given will be like dictated by some sort of software. Okay, basically we consider that thing as an operating system, so it does all that scheduling stuff for hardware. It decide like what activity should be done on our hardware and when exactly that activity should start. Okay, so it does this scheduling stuff, and basically that the software which is like controlling all that hardware. And it means when we combine these two things together, we would be able to like have like control of our hardware and get particular task done. Okay, but over here means this is just like a simple form. Okay, now what we want to do, we want to go further and we want to solve some like specific problem. Okay, it's not just about like performing some task means using that hardware, or like just not about operating system, but we want to solve something like bigger or some complex task. In that situation, we need to follow some basic level machine level architecture, and it generally consists of 4 parts. Okay, so we understood like how exactly storage are like developed. We understood how exactly this hardware and software interact. Now next thing is like, let's say there is like some custom program that we have written, and we want to implement that thing on that hardware. Then how exactly this thing will work out? So that some means how exactly that process should look like. That will be like dictated by this machine level architecture. Basically it consists of the 4 parts. Okay, so it will have like memory block over there. It will have like memory block in the beginning. So as I mentioned earlier, so we start with logic gates. We will have flip-flops. When we combine a lot of flip-flops together, we will get registers, and using this register we can build our memory. So memory are like of 2 types which we generally use in computers. First is like RAM and another is ROM. So random access memory is something like volatile kind of memory, and which can be like misused very easily. Okay, but this is the memory which we use very means too often. And then ROM memory is like this kind of permanent memory, and that's where we store our program. and whenever we have to implement that thing, we move that program from ROM to RAM. Okay, but that thing happens in like certain fashion. Okay, so we will have like two things over here. First thing is we will have like RAM over there, and we will have like ROM over there. Okay, so basically just try to understand, like there are two blocks over here. One is a RAM and another is a ROM. Then there is like second element which allows to do this thing, and it again consists of two parts. First is arithmetic logic unit. Basically, this is where all the operation, all those arithmetic operations of like addition, subtraction, multiplication, division, and all other things, all other logical operations are performed inside the second block. Okay, basically, generally we call it as like processor. So we have like arithmetic logic unit over here, and what operation should be performed at that particular instant, that will be like told to this ALU unit from by control unit. Okay, so we will have like two blocks over here. First is the control unit, and second would be arithmetic and logic unit. Okay, so just let me write this thing over here so that it will be easier for you to understand. So we have like RAM over here, we would have ROM over here, then over here we will have like control unit plus arithmetic and logic unit. Okay, so these are the two blocks we have over here. So interaction generally happens between these two units, and then we have like two more blocks over here. First is like input, and then another will be like output. Okay, so basically just to take input from user and like give some sort of output to user. So these are like two additional blocks that we need to have over here. But when we like put them, so this is like just basic architecture that we can use to like solve our custom problems. So this will be input and this will be output. I should have written this thing. Okay, so just try to understand, like here we have input and here we have output. So generally what happens whenever we have to solve any custom problems, in that situation, we write down our program using editor. Then we store, we compile that thing, we debug that, we convert that into executable that we store here in ROM memory. Then whenever we have to execute that thing, we just run it. And whenever we are running that particular program, what we do, we try to move that all that sequence of instruction from ROM to RAM, and then control unit. What control unit does at that moment? Control unit basically has some sort of counter over there. Okay, so at each instant or for each clock pulse, control unit will take like one instruction from RAM, and that instruction will be like conveyed to this arithmetic and logic block. And based on input it has received from input, arithmetic and logic unit will like perform some operations, and it will store those results in ROM memory or like RAM memory based on like requirement. And then if it's like final output, then that output will be like provided over here. Okay, and whenever that particular instruction is executed, counter will be like incremented by one, and then it will like take another command from RAM. Okay, so that way it will like execute that entire code, and we will have like our entire custom code executed by this simple architecture. Okay, so basically whenever, so you understood, right? So basically we start with storage and computation, storage or like some sort of operations. In order to do that thing, we need some sort of hardware. So we start with logic gates, then we move further, we build uh, these flip-flops, then register, then some sort of memory devices, so which are over here. Then we store program over there, we move that program whenever we have to run it to RAM memory, and then using control unit and arithmetic logic unit, we try to execute it, and we try to convert some sort of input into desired output. So this is the basic architecture that we follow whenever we have to run any sort of program. Okay, and whenever we have to solve complex problem, then just this like means the instruction that we are writing over here, like means whenever we are writing that program, so that thing will change. But whenever you have to like solve like a lot of things at a time, like whenever you have to do parallel computing or cloud computing, in that situation this basic architecture will change. Okay, I hope these things are clear to you guys. Are we good? Or do you have any question?
Yeah, good for me.
Okay. Yeah, so now let's talk about programming languages. As I mentioned earlier, yeah, thank you, sir. So as I mentioned earlier, computer just understand a language of zeros and ones. Okay, it does not understand anything apart from that. It just understand what means like zero is being received and or like one is being received and like this is the operation or sequence means this is the command that we have to execute. It does not understand anything else. So whatever custom code that we were talking about in earlier slides, so basically it involves like means all that bunch of zeros and ones, and basically that is a language computer understand, and that language is something we call as like machine language. And the code that we get over there, so that's something we call as like object code or something like that. Okay, basically after compilation stage we will get this machine language code. Okay, but the one thing that you should understand over here is the way we human understand our languages, like let it be English or let it be another language. So the way we understand this language, and in similar way, computer can only understand only means this machine language, okay, and nothing else. And whenever we try to, and in order to make us to interact with that computer easily, what we do, we try to develop like some abstract kind of languages. Okay, so first they came up with like assembly languages, so that they could communicate with computer more easily. And basically what they were doing is using that assembler. They were like just converting that assembly language into uh, that machine language. Okay, so basically assembly language is like assembly language is some sort of like intermediate language that is really not that readable to humans, but it's easy to write. Okay, we could like give some sort of instruction, or we could write, or we could develop some like complex programs using that assembly level language, and then just passing it through assembler, we could get converted into machine language which computer can understand. So this is the like second language which is there. But again, as I mentioned, so assembly level language is again not that great for human to understand, and to have like this smooth interaction with our machine, with our computer. What we need is like we need some sort of language that human are really, I mean, which is quite readable to humans. And using that language, we are really means we would be able to like express ourselves more properly. Okay, so that's basically high level language. So all the languages that you see over here, like let it be Python or like another language, let it be like C++ language. So all these languages are high level language. Okay, so it depends on like how close, means how fast they can go close to machine level language. But basically these are like high level language which human can understand. Okay, again there are like two classes when it comes to high level languages. One is the interpreted language. Basically what happens in case of the interpreted language, when you write that code and when you try to run that thing, so that code will get compiled at the time of running only, and then you will get output. Okay, so at runtime only that code from high level language will be converted to machine level language, and then computer will execute that thing. So basically those languages are interpreted languages, and Python is one of them. Okay, so today we're going to study Python programming language. And yeah, so you should understood like Python is interpreted language. So basically it runs when you execute your code. But the thing is that like it runs properly. Okay, it's easy to understand, it's easy to write code using Python programming language, but it has like certain drawbacks. Okay, so you might see like you can just like print something using just single line of code, but at the uh, beneath that particular mask or particular that line, there is like a lot of code which is going over there. Okay, and that's the reason Python or interpreted languages are quite slow. Okay. uh, so that this is interpreted language. The drawback about interpreted language is like they are quite slow, and means there are certain situation which might appear at runtime, and we don't want to deal with those problems at the runtime, because if some problem arises at runtime, and if that code is not compiled, if that code is not tested earlier properly, then our program or our system might fail, and that's like big loss, right? So that's the reason we generally don't go for interpreted languages when it comes to safety systems. But in general, whenever you have to build prototype for anything, then people generally tend to go for interpreted languages like Python. And when it comes to building like safety critical applications, or like some applications where speed is really necessary, people try to go for compiled languages. So basically what happens in case of the compiled languages, you write code in editor in the beginning, then you try to compile it using compiler, then compiler will convert entire code at the stage of compilation only into this executable code or binary code, and then that executable or object code is something fed into machine. So we are sure that like there is no error included in our code, okay, or means we are able to deal with all the errors, or like we would be able to like deal with all the issues which might appear during runtime. So basically it's not like means it's not being compiled at the time of running. It is compiled earlier, or it's compiled even before we run it on any particular system. So these are like two categories of high level languages. But yeah, this is like entire thing that we see when it these are the all languages that are there when it comes to computers. First is machine language, which computer understand. Then like abstract version of that, and that's something called assembly language, which machine doesn't understand, neither human, but it's more easy to like communicate to computer using that assembly language. And it's quite simpler than machine level language. Okay, and then there is like third language which human can understand, and we would be able to like convey our expressions more in more better way using those languages. So those are like interpreted and compiled languages. Okay, so this is like upward graph that means this is like flow, right? Means machine level language, then above that there is assembly, and there above that there is high level language. But thing is that when as a programmer, when you or me as a programmer write down any code, so basically that code is in high level languages. Okay, so if you have to convert that code into language that computer understand, when we want to convert that code into machine level language, so in that situation what we need to do, we need to compile our code. Okay, so this is like flow that I mentioned over here. What we generally do, this is the flow generally we like go for when it comes to like compile languages. For interpreted languages, we really don't need to do this thing. This is just that we need to do when it comes to like compile languages like C++. So we write down code, then we compile it. If there are some issues or errors, then we debug it, and then whatever executable that we are getting, we try to run it on machine. So this is the flow that we try to follow to move from that high level language to machine level language. Okay, so I would like to talk a little bit more about this compilation procedure. Okay, because this compile means I'm just saying like compile it. Okay, but it's just not like one single step, rather like 3-4 steps are going on inside that particular process. So first of all, what happened, so let's say you have written down code in C++. So .cpp file is something you have written, and in the beginning what you generally do, you try to add some header files over there, right? Using that hash keyword, you try to like include some sort of like some sort of header files over there. So basically you are including some sort of libraries over there. Okay, so when you compile, so basically what it does, you try to call all those, you try to recall all those libraries, and try to paste all those libraries in the beginning of your code. Okay, second thing it does, it try to remove all the comments, and it try to make code as clean as possible. Okay, so that's the preprocessor stage, and this is something which is happening at the preprocessor stage. Once you get like entire code ready, means obviously it will again be in like high level language. Then you pass that code through compiler. So compiler is something which will convert that code from high level language to assembly level language. Then assembly level language code will be converted further into machine level language using that assembler. So let's say like you are doing and basically that code, the one which we convert from assembly level language to machine level language, so that code that we have in machine level language, we call that code as a object code. Okay, or executable. But thing is that, but that's not the final object means executive. So thing is that when we get that object code, and let's say we are like trying to build really complex system for our this particular application, so in that situation that object code is not enough. What we need to do over there, we need to link a lot of object code together in order to form like final executable. So that's something we are doing inside that linker stage, which link all those object codes together, and then we get final executable. That's something we can run our machine. Okay, so people tend to use like CMake or like something like that in this situation to like compile, means get this entire procedure done. Sometimes we can also use GCC compiler to get this compilation done. Okay, so if you are using like visual code, so in that situation you will understand like you need to download that GCC compiler, and then you need to add that part to this like as an environment variable, and then you would be able to get this compilation done. But yeah, these are the steps that you need to follow. I hope all these steps are clear to you. Then there is a Python interpreter. Okay, so yeah, before going over here, guys, there is one thing that I want to tell you. So this meeting is just for 40 minutes. Okay, so whenever this meeting ends, uh, over here, like in that meeting invitation itself, like I have shared one more thing. I mean, I have included invitation for the second meeting. Okay, which is supposed to start at 7:40. Try to join again using that meeting. Okay, so you just need to copy this link and you have to like copy and paste over here, and then you have to join again. So that's something you have to do, but you're not now. But whenever this meeting ends, try to join again using that link. Okay. So that's the instruction. So let's discuss this Python interpreter part. So basically, as I mentioned earlier, we write down code using some sort of editor. It could be like means visual code. It could be like a Sublime or any kind of editor. So basically, we try to we write down high level language code, and in order to computer to understand it, what it need to do, it needs to have that code in the form of like a machine level language. Okay, so what happens, this Python interpreter kind of thing is over there. Okay, so it will convert, or it will basically compile that code, and it will convert that code from high level language to machine level language at runtime only. So that's the job of Python interpreter. So basically what happens when you start, or whenever you start execution of any code, after initialization phase, it will fall into this interpretation loop, and then this interpretation loop will keep on going again and again and again until it delivers like final result. Okay, so that's something happen inside Python interpreter. So basically it's like a language interpreter only. Okay, so let's say I'm speaking English, I'm speaking in English, and then there is like another person who is speaking like another language, and if you use like interpreter between two of you, then it would be easier for you to like communicate. Okay, so this is something Python is doing over here, and that's something happening at runtime. Okay, and whenever Python is not able to understand what exactly one, I mean, high level language code is saying, then it shows up like there is error, and there are like two kinds of error are there. Okay, so first error is like syntactic error. Okay, whenever you are having error in your syntax, so we call that as like syntactic error. And yeah, Python is like good at capturing, or mostly like all the editors that you see out there, so those editors are really good at capturing those syntactic error. But whenever there is error in logic, so that error is something we call it like static semantic error, and for that purpose we need to perform a lot of tests. Okay, so guys, we have just like one more minute. So what I'm doing right now, I'll stop recording, and then I'll like stop this meeting.